Hello again. What I thought I'd like to do is give you a little bit of part two in terms of the introduction of this course by talking through a few things we've done in the Centre for Machine Vision as a bit of background, really. This is a website I rigged up recently showing a few things that we've done. So just if I go on to talk a little bit about some of the projects we've worked on, maybe. Well, I put a news article on here. And let's just have a look at a little bit of these projects here. So weed analysis I talked about a minute ago. Polarization project that Gary's working on. Face recognition, I was talking about that a little bit earlier. Pig face identification, we've got some good work going on with deep learning and CNNs in relation to identifying pigs, as well as actually determining their emotional state, if you can believe that. Because if you identify them by looking at their faces, which is difficult for us to do, but not so difficult for a computer, when it's trained for it, deep learning, you can avoid having to use these tags, which are thereby reduce the suffering of the animal, and also determine whether the animal's in distress, which helps with its welfare. Another big area we've got is imaging plants. So here we've worked with Edinburgh University, and they've got these growing machines, and they have a plant called Arabidopsis. And the idea is that they change the water, the nutrients, the lighting and so on, and they want to see how well it grows. And the cameras they've got at the moment, or used to have, are just 2D. So if the leaf is changing in orientation, which it does a lot, then they don't get accurate measurements of the actual area of the leaf. But because we can measure it in 3D, we can compensate for that rotation, parallax effect, and get a more accurate measure of how it's changing. So that's been something we've worked on with them and got some good papers up together with Edinburgh University. Another thing I've been working on recently is a handprint recognition, which is relevant to COVID-19, because the idea here is that it's completely non-contact, and you put your hand above a camera with some special lighting, and it recovers, you can see here, the whole hand at high resolution. It's a bit like a fingerprint, but it's recovering at high resolution. You use it to access all sorts of places at the moment where you use a fingerprint. But these fingerprint machines, of course, have got a chance of contamination and not so hygienic as completely non-contact vision-based work. So we're just getting a paper up together on that, and also we're trying to get some money for research on that one. Gary did a work on cow digestibility, which was with Aberystwyth University, which went pretty well. I was working on this one, which was with the company down here in Somerset, looking at cow monitoring. So we developed a system that uses 3D cameras to measure the condition of a cow, which actually is very important because it's related to how healthy they are, and the farmer wants to keep them in maximum condition to get the maximum milk out of them. So this system measures them as they go through into the milking parlour. And it isn't just an academic exercise, because we've used this for many years. We developed it, and it's being used all around the country. Arla, the milk company, are actually buying into it, and we've already got it at about 20 different locations around the UK. So our projects have got a lot of industrial impact. I think there's enough material in that one for an impact case study, as it's called, by itself. And then that would contribute to something called the Research Excellence Framework, which is a government scheme run every 4 years. If we get a good review in that, we get more money for research. So that kind of work will help UWE. We did another project for Autoglass on measuring cracks in windows. So the idea is you get a chip in the window, you use a smartphone, and then that tells the bloke come in exactly what to bring with him to fix it as well as possible. Now, we got this working for them, which is quite difficult to do because there's lots of noise in the background of the images typically, but they were quite happy with what we did. And they went on to ask us to do another project on dents in bodywork, actually, which was quite good as well. So this is just a taster of some of the things we've done. This is a 3D thing of me, actually. In the lab, we've got this system called 3DMD, which we spent £85,000 on. It's coming from a company in Atlanta, but it does measure three-dimensional complex objects like heads very accurately. So we used it in a project where we were measuring babies' heads for a condition called plagiocephaly, where the head is asymmetrical after birth, and you can be corrected by various prosthetics. That went quite well, that project. There's quite a lot to it. It was quite interesting. We bought that system for that project. So just to give a little bit of background where we come from in the lab. Oh, this is pictures a bit before a few years ago. This is Abdul, who will be helping you in the tutorial. Dr. Abdul Farouk will be helping you in the tutorials, which, as I say, will involve LabVIEW and Vision Assistant. And I will be dealing with the lectures, which I'm recording at the moment. This is Mel I was talking about a minute ago, who's the director of the lab. That's a video he put onto YouTube, which was talking about this technique I mentioned, photometric stereo, and applying it to bath tiles, actually, in that case, for quality control of tiles. Because we did a lot of work with tile manufacturing companies and people who made the machines for inspecting tiles. Because, you know, being able to determine the difference between a 3D and a 2D defect on a tile that you're making is actually quite important, because the manufacturer of the tiles wants to know if there's a problem, where the problem is. You know, is it a moulding problem or is it a printing problem? And that's what this system can do for them, really. So it was quite interesting for them. That's another video which went onto YouTube, but with me talking about a thing called the skin analyzer, which I'll probably spend a whole lecture talking about. But basically, it's a device which we developed over the last 18 years and used with 1,000 NHS patients. And again, it uses photometric stereo with one camera, as you can see, and a set of lights. And it's able to recover 3D textures from pigmented lesions. And the reason for doing that, of course, is that lesions, moles, if you like, can sometimes become suspicious or turn into cancerous tissue. So there's a lot of emphasis. So when someone goes to a doctor with a mole they're worried about, the doctor doesn't typically have a lot of training in it. So they send them to the Southmead Hospital, to the clinic there. But that means the clinic's full of people who don't have anything wrong with them. And that's expensive for the NHS, as well as, of course, potentially masking anybody who does have something serious. So the idea is to develop this device which we can then measure it automatically for the doctor and give them metrics and measure change in particular, which I think is something that's very valuable, really. So, so that's what that involves. We're just trying to get some money to continue developing that. That's the Mark III device that Abdul designed, you can see there. So publications, that's something we've been working on, just a few here, but this is something we've been working on for many years, and we try to get, you know, best publications we can, journal publications being the most valuable, of course. And then there's other links as well here, and contacts and so on. So that's just a very brief introduction to some of the things that we've done in the Centre for Machine Vision. There is another, there are other mentions of us, of course, in the BRL website. We are mentioned, and we also have our own link on the BRL website to our own website, which you can have a look at as well. So this is by way of some background information. And each one of those things I mentioned there could be, I could go into much more detail. I've only mentioned one or two things we've done here. For example, we did a project with the London Underground, or for the London Underground, which is operational now in central London using a three-dimensional face recognition system. And that's it there. That's the system that we were developing for that. You can't see the cameras that are above, the cameras and lights are above, you get in the picture there. And the idea is that you don't have to mess around with going buying tickets and fooling around with tickets. You just simply walk in as though you walk into a supermarket, and the system would know you're there, and it would automatically do that for you. Only for people who wanted to do it. We're not talking about surveillance. We're just talking about helping people who want to make their lives easier, really. And we got it working, and it's operating in central London now. But the thing is that the paddle gates that they're using at the moment are still working for the company we worked with quite well. So it'd be a case of when they decide they want to move beyond that technology, they can implement this vision technology very easily by making use of the system we've already developed for them. So that's just a sort of crash course introduction, if you like, to a few of the things we've done in the lab. And I will go into more detail later on of some of the more interesting sort of developments and techniques we developed and have emerged in some of these projects. We've developed systems for released and supplied to clients all over the world. United States, started in the United States. That's how we set up the lab back in '99. And Europe, all over Europe, Iceland, India, all over the place, really. So international. And we try to get a mixture of public and private funding for the projects. So I hope that's of interest. Meanwhile, I'll see you guys next week. Thanks very much.